Question 11. Purple paint is made by mixing red paint and blue paint in the ratio 5:2. Jan has 30 litres of red paint and 9 litres of blue paint. What is the maximum amount of purple paint he can make? Okay, we're going to start by looking at this ratio of 5:2. So let's think of this as 5 litres to 2 litres. So for every 5 litres of red paint I need 2 litres of blue paint in order to make this purple paint the correct colour. So if Jan has got 30 litres of red paint, well, that means that he's got, 30 divided by 5 is 6. So he can get 6 lots of this ratio. So 6 lots of 5 is 30. And 6 lots of 2 is 12. So in order to make the purple paint, he would need 30 litres of red paint and 12 litres of blue paint. So he has enough red paint, but he doesn't have enough blue paint to make that mix. So that one's not going to work. So let's get rid of that and let's try, let's do 9 divided by 2 now. So now that's 4.5. So let's do 5 times 4.5, which is going to be 22.5. And let's do 2 times 4.5, which is 9. So that's going to give us the correct shade again. We're going to need 22.5 litres of red paint, and we're going to need 9 litres of blue paint, which is exactly what we've got. So that gives us the most that we can make. So I'm going to I'll write it down over here. We want 22.5 to 9. That's going to be our mixture, and that's going to give us 22.5 litres of red paint plus 9 litres of blue paint, which in total is going to give us 31.5 litres of purple paint. So my answer here is going to be 31.5. Question 12. A r to the power of b all to the power of 4 is equal to 16r to the power of 20, where a and b are positive integers. We need to work out a and b. Okay, so I'm going to start by writing this in expanded form. So a r to the power of b, if I raise all of that to the power of 4, that's going to be a to the power of 4 times r to the power of b to the power of 4. So that'll be 4 times b. Okay. And we're saying that's equal to 16r to the power of 20. Okay, so all I've done here is I've taken a to the power of 4 and r to the power of b to the power of 4 and achieved that there. So that means a to the power of 4 must be equal to 16. And r to the power of 4b must be equal to r to the power of 20. So let's deal with this first of all. A to the power of 4 is equal to 16. That means that a would be the 4th root of 16, which is 2. So a is equal to 2. That's because 2 times 2 times 2 times 2 gives me 16. Okay, and then if r to the power of 4b is equal to r to the power of 20, that means 4b must be equal to 20. And if 4b is equal to 20, b must be equal to 5. So a is equal to 2 and b is equal to 5, and that will work. Question 13. In a class of 28 students, the mean height of the 12 boys is 1.58 meters, and the mean height of all 28 students is 1.52 meters. We need to work out the mean height of the girls. Well, straight away I know that there's going to be 16 girls, because that's 28 total students, take away 12 gives us 16. So we know there's going to be 16 girls. I'm just going to jot that there to remind me. Okay, so, well, if the mean height of the 12 boys is 1.58 meters, I know that the total height of all of the boys must be 12 times 1.58. So total boys' height is going to be equal to 12 times 1.58, and That's going to be 1.58, 18.96 meters. Okay, the total height of everybody, so of all 28 students, and that's going to be equal to, well, that's 28 students had a mean of 1.52, so if I added all those together, it should be 28 times 1.52. So we've got 28 times 1.52, and that gives me 42.56 meters. Okay, and just to remind you about why that works, when I'm working out the mean, I add them all together and divide by how many there are. So if I found out the total height of everybody and I've got 42.56, to work out the mean, I would divide by 28, and that would give me 1.52. So that links together and that relates together in that way. Okay, so we know the total height altogether is 42.56. I know the total boy's height is 18.96. So the total girl's height well, that's going to be the total of everybody's height, which is 42.56, take away the total of the boy's height, which is 18.96, and that gives us 96. That gives us 23.6. Okay, so the total of the girl's height is going to be 20.3.6 meters. Now, we worked out earlier that there's 16 girls, so to work out the mean height of the girls, we want to take the total of the girls' heights, which is 23.6, so we want to divide it by the total number of girls, which is 16. So divide that by 16, and I get 1.475. So the height is going to be 1.475 meters. Question 14. X, Y is equal to C, where C is a constant. We need to decide on which of these statements is true. So I'm going to start by writing this in a slightly different way. I'm going to make Y the subject. So that means that Y is equal to C over X. That might make it a little bit easier for me to spot what's going on. Well, Y is directly proportional to X. That's not going to be true, because that would be Y is equal to CX. Y is inversely proportional to 1 over X. That's not going to be true either. In this case, Y is inversely proportional to X. So that's not going to be true either. Y is directly proportional to 1 over X, and that looks like it's true because Y is equal to C times 1 over X. So it's going to be this one here. Y is directly proportional to 1 over X. And X is directly proportional to Y. That's not going to be true either. So we found our correct answer. Question 15. The graph shows the depth of the water in a harbour for 12 hours. D is the depth of the water in a harbour in meters, and T is the number of hours after 9 AM. For part A, we need to we need to know for how many of the 12 hours is the depth more than 5 meters. Okay, and to help us answer this question, I'm just going to draw a line going along from 5 meters. So draw a line going across from 5 meters, and we can then see how many hours it's above the line. So we've got 7 hours, and then between 7 and 11 hours it wasn't, and then for the last hour it was. So we've got 7 plus 1, which is 8 hours. Okay, part B says, by how much does the depth change between 12 noon and 4 p.m? So T is the number of hours after 9 a.m. So 12 noon would be 3 hours after 9 a.m. So let's go for our lines here again. So 3 hours after 9 a.m. And at that point it was 8, they had a depth of 8 meters. And then 4 p.m. would be 4 hours later, so that was over here at 7. And at that particular point it had a depth of 5 meters. So the change, it's gone from 8 meters to 5 meters. So it has a change of 3 meters. Question 16. The value of a new car is £18,000. The value of the car decreases by 25% in the first year, and then 12% in each of the next 4 years. We need to work out the value of the car after 5 years. So it's £18,000 originally. So I've got 18,000, and the value of the car decreases by 25%. So if I decrease by 25%, I've gone from 100% to 75%. So I know that I need to multiply this by 0.75. So let's do that first. I know that 18,000 times by 0.75. 1, 2, 3. And that should be £13,500. £13,500. Okay, and then it decreases by 12% in each of the next 4 years. So we've now got 13,500, and we want to times that by, well, a decrease of 12% would go from 100% to 88%. So that's going to be 0.88, and then that's for the next 4 years, so I need to times it by 0.88 4 times, but I can write that as 0.88 to the power of 4. Okay, and then using my calculator again, we want to times that by 0.88 to the power of 4, and that gives me £8,095.89. So over here, £8,095.89. We'll put a pound there. Question 17. Liam drives his car. He drives the first 9 miles in 9 minutes. He then drives at an average speed of 70 miles per hour for 1 hour 36 minutes. He finds this information about his car. When the average speed is 65 miles per hour or less, the miles travelled per gallon is 50. When his average speed is more than 65 miles per hour, then the miles travelled per gallon is only 40. We need to use the information to show that his car uses less than 3 gallons of petrol for the drive. Okay, so first of all, let's find out the speed he was going over here. So he drives the first 9 miles at 9 minutes. So that's 1 mile per minute, which is 60 miles per 60 minutes. So that there is 60 miles per hour. Okay, so we know that initially he's driving 60 miles per hour, which will be less than 65 miles per hour, so it's 50 miles travelled per gallon. So let's concentrate on this part first of all. So 50 miles would be 1 gallon. Okay, so if I wanted to know what 1 mile would be then, well, I've divided by 50 over here, so I need to do 1 divided by 50 to work out how many gallons that would be for 1 mile. And 1 divided by 50 is 0.02, so it would be 0.02 gallons. Okay, so 1 mile is 0.02 gallons, so 9 miles, I'd need to times that by 9, so I also need to multiply that by 9, so it's going to be 0.02 multiplied by 9. And that gives us 0.18 gallons. Okay, so that's what it's going to be for the first part of his journey. Okay, let's concentrate on the second part now. He then drives at an average speed of 70 miles per hour for 1 hour and 36 minutes. So we need to know how far he travelled during that time. Now, 1 hour and 36 minutes, well, that's going to be 1 and 36 sixtieths of an hour. And 36 sixtieths of an hour is basically 0.6 of an hour. So 1 and 36 sixtieths of an hour is the same as 1.6 hours. Okay, so he's gone 70 miles per hour for 1.6 hours. So we'll write this down over here. So 70 miles per hour for 1.6 hours. So the total travel during that time is going to be 70 times 1.6. 70 times 1.6, and that gives us 112 miles. So he travels for 112 miles during this 1 hour and 36 minutes. Okay, so we know that it was 70 miles per hour, so it's going to be this part of the table we're looking at, and he does 40 miles per gallon. So if he's travelled 112 miles, we need to do for the total used, so the total fuel used, we're going to do 112 divided by 40. Okay, 112 miles divided by the 40 miles per gallon, and that's going to give us 2.8 gallons. So now to work out the total that he's used in both parts of the journey, we're going to do 2.8 plus 0.18, which gives us 2.98 gallons. And that we can see is less than the 3 gallons of petrol that we were trying to show. Question 18. Nick sketches the graph of y is equal to 0.5 to the power of x for when x is greater than or equal to 0. We need to make one criticism of his sketch. The thing to notice here is that when the x coordinate is 0, then y would be equal to 0.5 to the power of 0. And I've replaced the x with a 0. And 0.5 to the power of 0 is actually, well, anything to the power of 0 is 1. So when x is 0, y should be 1, not 0.5. So we need to say that when x is equal to 0, y is equal to 1, or y is not equal to 0.5. Okay, so as long as we've made it clear that that's what the error is with this graph, that should be fine.